Compel the mind autonomous.
You describe what you want, the AI writes the code, and the feature ships. Suddenly, backlogs vanish, and productivity charts slope sharply upward. It is the utopian promise of the AI coding gold rush. Then, on a random Tuesday, a checkout flow quietly melts down, or a pricing rule flips, or a customer data pipeline starts perfectly processing absolute garbage without triggering a single alarm. We are seeing a massive mismatch in software development right now. Teams are adopting generative tools at breakneck speed, but their discipline for actually checking that generated code is lagging far behind. Google's 2025 DORA report, a major industry survey on developer operations, shows exactly how cautious engineers remain. Right now, only 24% of respondents say they have a high degree of trust in AI-generated outputs. That caution comes from direct experience. The danger isn't that the model always writes obviously broken code. The real danger is that it writes highly plausible code that smoothly hides deep structural flaws. If your organization only measures how many lines of code are produced or how many tickets are closed, you are walking into a trap. You are mistaking frantic digital activity for actual operational progress. As code volume rises rapidly, a shaded red area grows underneath it. This is error debt, hidden mistakes that accumulate when changes outpace review. Like accounting shortcuts, daily numbers look fine until the weight of unseen errors causes a sudden system failure. But there is a second, far more dangerous liability: comprehension debt. This is the widening gap between the sheer volume of software your company owns and how much of it your human engineers actually understand. You spot this debt in daily operations. Pull requests, the formal proposals engineers use to suggest edits to a shared codebase, get thinner, with descriptions that basically say, the AI did it. When an incident happens, recovery drags on because the team has to rediscover the system's intent. Eventually, engineers become afraid to touch their own mystery wiring. By rubber stamping AI outputs just to build faster, a company is not innovating. It is actively eroding the human understanding required to safely maintain its own digital infrastructure. When reliability wobbles at scale, theoretical debt becomes a very real financial problem, and operational leaders act quickly to lock down their systems. In March 2026, the Financial Times reported that Amazon convened engineering meetings to address a string of internal incidents. These outages were explicitly characterized as having a high blast radius, linked to generative AI-assisted changes. Amazon quickly published a rebuttal disputing the exact cause of those specific outages. But regardless of the specifics in that one case, the broader industry takeaway is clear. Major engineering organizations are heavily tightening their governance gates for any high-impact system. That tightening is necessary because the code itself often contains direct security liabilities. The 2026 GitGuardian report detected over 28 million leaked secrets in public code repositories. This animated chart illustrates the most critical finding from that report. Compared to normal baseline code, the AI-assisted bar shoots up to exactly twice the height. Developers using AI are leaking digital secrets, like API keys and passwords, at double the normal rate. AI acts as a massive accelerant for security flaws, multiplying the risk of a breach whenever teams treat a draft as a finished product. Right now, solving this mounting debt requires a rigorous upgrade to how the organization drives and supervises AI implementation. Leaders must accept a brutal economic reality. Artificial intelligence takes the financial and operational cost of software development, removes it almost entirely from the act of writing, and dumps it squarely into the act of verifying. Buying a faster coding assistant will not save an engineering team from bad habits. Safety requires an explicit, disciplined workflow that forces human accountability back into the loop. Using structures like Brock's Let's Mode, teams enforce a strict sequence. First, research what you're touching. Then, plan how you'll prove the change is safe. Finally, build. Engineers make small, verifiable changes, explicitly inventorying dependencies and writing testing guardrails before altering the software. If an organization refuses to fund the time required for this verification loop, they are not saving money with AI. They are merely deferring a massive operational disaster. This disciplined workflow applies directly to everyday production realities. It stops a developer from pushing a quick AI-generated bug fix today that silently causes a massive outage tomorrow, and it is the only way to stage a large system migration safely. This grinding, meticulous reality stands in sharp contrast to the flashy marketing hype surrounding AI coding benchmarks, like SW Bench Pro. SW Bench Pro is a specialized evaluation used to measure how well an AI agent can solve complex, long-horizon software engineering tasks. But those benchmarks are a trap. A high score achieved in a highly constrained, theoretical test environment does not mean the agent will write safe, production-ready code when dropped into your company's messy, undocumented legacy systems. Furthermore, as these AI workflows consume massive amounts of data through heavy context windows, token-based pricing kicks in. A token is a chunk of text, roughly 3/4 of a word, that an AI processes as a single unit. Because platforms charge by the token, the sheer volume of unchecked code generation can quietly drain an engineering budget if left unmanaged. To survive the AI gold rush, leaders must stop driving blind. They must abandon vanity metrics like total code volume and instead build an engineering culture where rigorous verification is the ultimate measure of progress.
Pseudo-spawn agentic. Compile the mind autonomous.